Hi guys, welcome back to day 5 of our math lessons. We will be doing 12.5 today. So go ahead and grab your book, grab your pencil, and we will get started. Today we're going to be doing line plots. Line plots are a way to graph data that you acquire or get during math or science. Okay. So it says, how can we make and interpret line plots with fractional data? Okay, with fractional data. So we're going to be using fractions today. And we're going to be both making and interpreting. Interpreting just means figuring out what the information on our line plot means. Okay, so our first problem says the data show the length of the buttons in Jen's collection for an art project. She wants to know how many buttons are longer than 1/4 inch. So we're looking for buttons that are longer than 1/4 inch. You can use a line plot to solve the problem. A line plot is a graph that shows the frequency of data along a number line. Make a line plot to show the data. So the first thing we want to do when we're going to make a line plot is to order our data from least to greatest. So from smallest to biggest. So the data they gave us is up here in this little chart. So I need to look at my fractions that are up in here, and I need to figure out which one is my smallest unit of length. This is the smallest unit they gave me. Good, I see some 1/4 in here. So I'm going to write down all the ones I see. So I see a 1/4, a 1/4, and a 1/4. That's 3 of them. So I write all 3 down. I'm doing all of my data for my box in least to greatest order. So if I have 3 of the same thing, if I have 2 of the same thing, I still have to put them down. Okay. Looking at what's left, I have 3/4, and I have a 4/4, and a 4/4. So what is the next smallest fraction? 3/4 or 4/4? Good, 3/4. And then I will put on my 2 4/4. And now I've listed my data from least to greatest. Okay, so label the fraction lengths on the number line below from least to greatest value of your data. So the reason we order these from least to greatest is because when we go to make our line plot, we want to always make our line plots in order from least to greatest. So I'm going to look here, and I have 1/4. And then if I look, I have 3/4 and 4/4. But there's a number in between there. What goes in between 1/4 and 3/4? Good, 2/4. Okay, and then my 4/4 at the end because it's the biggest. Okay, this line down here is so that we can label our line plot. When you are making graphs or data charts, you always need to label what you are doing. So what we are showing in our graph can actually be found above our data. So we are showing the length of buttons in Jen's collection in inches. So this part's very important. You need to always use this part in your label. So I'm going to take the beginning of that. I'm going to say length of buttons and then in parentheses, I'm going to put in inches. Okay. Our third step says, plot an X above the number line for each data point, write the title of your line plot. So we got our title in there. The next thing would be to create our line plot by putting X's above these here. Before we can do that, we need to fill in our tally chart. So I need to look at my least to greatest here, and I need to say, how many 1/4 do I see? So I can count them up. I see 1, 2, 3. So I would have 1, 2, 3 tally marks here. What about 3/4? How many 3/4 do you see? Great, 1. Okay. What about 4/4? How many 4/4 do we see in our list of least to greatest? Wonderful, 2. Okay. This tallying will help us with how many X's we have to put above our line plot. Okay. So when I look at my 1/4, I see that there are 3 tally marks next to it. So that means I should do 3 X's above the line for 1/4. If I look for 2/4, I don't have any 2/4 over here. So it's not going to have anything above it, and that's okay. Sometimes you will have numbers that don't have anything up above it on your line plot. Then I look at 3/4, and I see there is 1 tally mark. That means I do 1 X above it. How many X's am I going to put above 4/4? Good, 2. I have 2 tally marks, so I need 2 X's. Okay. Our next question says, so how many buttons are longer than 1/4? So I want to know how many X's I see on numbers that are bigger than 1/4. So all these ones above 1/4, I'm not going to look at because that is equal to 1/4, and I want greater than 1/4. So if I go along, I see 1, 2, 3. There are 3 buttons longer than 1/4 inch. Our next question asks us, how many buttons are in Jen's collection? So how many buttons are in her whole collection? So to figure that out, I would add up all of the X's I see. So I can count 1, 2, 3, 4, 5, and 6. So there are 6 buttons. Don't forget to label your answers. Okay. My next question, or our next question, says, what is the difference in length between the longest button and the shortest button in Jen's collection? You will see these 2 questions a lot during this lesson about how many objects are in the chart in total. Like this first one kind of says about Jen's collection, so that's how many total we're doing. And then you'll also see this one about what is the difference. Okay, so difference means subtraction, right? Between the longest button and the shortest button. So I would find the longest button length, and that would be 4/4. And I would subtract the shortest button length, which is 1/4. Remember, when we're doing subtraction of fractions, we subtract across the top as long as our bottoms are the same. In this case, I have 4s on the bottom in my denominator, so I subtract across the top, and I would do 4 minus 1 is 3, and my bottom stays the same. So the difference between the longest button and the shortest button is 3/4, but I have to label. So you go back up here to what are you measuring in? So 3/4 of an inch. Okay. Another way to find the difference is start from your greatest number and hop backwards on your number line until you get to your smallest. So if I was to do that, I would start at 4/4 and I would go back 1, 2, 3 times. So it would be 3/4, or whatever my denominator is in that problem. All right, our next problem says, some of the students in Miss Lee's class walk to school. The data show the distance these students walk. What distance do most students walk? So what distance do most students walk? We want to know which one of our fractions has the most x's up above it. So the first thing I need to do again is order my data from least to greatest, okay? When I'm looking at this, I notice something right away. I notice that I have two different numbers in my denominator. I have a bunch of 1/2, and then I have some 1/4 and 1/3. So I'm seeing a 4 in my denominator, and I'm seeing a 2 in my denominator. So the first thing I need to do is take anything that doesn't have the same denominator, and we need to make common denominators so we can compare which fraction is greater and smaller for our ordering. So I know that a 2 can make a 4, so I'm going to take my 1/2, and I'm going to say I want to multiply it by something to get a 4 on the bottom. What would I multiply it by to get a 4 on the bottom of my new fraction? Good, 2. If I'm going to multiply the bottom by 2, I have to multiply the top by 2. So I would do 1 times 2 is 2. So 1/2 is the same thing as 2/4. And I'll need this information when I am, again, ordering from least to greatest. All right. So when I start looking at my numbers, I see 1/2, 1/2, which is really 2/4. So I have a 2/4, a 2/4, a 1/4, a 3/4, a 1/4, a 2/4, and a 2/4. So what is the smallest number out of those fractions? Good, the 1/4 is the smallest, but I have to make sure I get them all. So if I go by, I have 1/4 here, and I have another 1/4 here. So I need to make sure I write down both of my 1/4. Okay. After 1/4 comes 2/4. And we already figured out that 1/2 is the same thing as 2/4. So I'm going to write those next. I see I have 2 on this side, so I'm going to make sure I put those 2 on first. And then I have 2 over here, so I'm going to add 2 more. And all I'm left with is this 3/4 in the middle there. So I tack it on to the end, because 3/4 is bigger than 2/4. Okay. For our tally chart, last time they filled this in for us, but you do the same thing as you do on your line plot chart. You order these from least to greatest as you go down. So I put in my fractions here. So I have 1/4, I have 1/2, and I have 3/4. And because I've already figured that out here, I can use that same information and go across the bottom here. So that's 1/4, 1/2, and 3/4. Okay. Next thing I'm going to do is make my tally marks. So I'm going to count how many 1/4 do I have. I have 1, 2. Make sure I have 2 tally marks here. Then for 1/2, I have 1, 2, 3, 4. Make sure I have 4 tally marks. And then for my 3/4, I have 1. Now I can take these tally marks and I can put them above my numbers in the form of x's. So I have 1/4 and I see 2 lines, so that means I need 2 x's. I see 1/2, I have 4 lines, so I need, wonderful, 4 x's. And then for my 3/4, I see only 1 line, so I need 1 x. Now I'm not done with my line plot because I have not yet labeled it. Excuse me. I need to label my line plot. So what is this information that I'm showing? Remember that we get that from right here. Okay. So I can write in the same exact thing right here. So distance students walk to school. We can't forget the special parentheses in miles. Okay. Remember, as we were doing this, we wanted to find what distance do students walk most. So which one has the most X's above it? Which length has the most X's above it? Good, 1/2. 1/2 has 4 X's above it. So most students walk 1/2. Don't forget what you're measuring by. Okay, 1/2 mile. Our next one asks us how many more students walk 1/2 mile than 1/4 of a mile to school. So we need to use this information from our chart to figure this out. First, we need to figure out how many students walk 1/2 a mile. To do that, we would go to our 1/2 mark and count all the X's above it. Good, we should have counted 4. 1, 2, 3, 4. So 1/2 mile has 4. How many does 1/4 of a mile have? Good, 2. So it says how many more? That is subtraction. So I would do 4 minus 2 equals good, 2. So 2 more students. Remember, don't forget to label on your word problems. What are you telling me? If you just put a 2, I don't know if you're talking about 2 ice cream cones, 2 chocolate chip cookies, 2 llamas, I don't know. You have to label it. Number 4 says, what is the difference between the longest distance and the shortest distance the students walk? So remember, this problem is just like we talked about on number 2 at the bottom on the last page. And there are 2 ways to do it. You can do a subtraction problem, or you can do leaps on your line plot. So what is the difference between the longest and the shortest distance? I start at my longest distance, 3/4, and I'm going to take hops backwards to my smallest distance, and I'm going to count them. So I go back 1 and then 2. Okay. And you take that number and you put it over your denominator. So it would be 2/4, okay, which we know is also 1/2 from the work we did above. I need to make sure I label it by what are we measuring by. So 2/4 or 1/2 mile. Okay, that's if you're going to do the leaps. Okay, if you're going to do a subtraction problem, you take the biggest fraction and you subtract the smallest fraction. Remember, if the bottoms are the same, you just carry it over and then you subtract the top. So 3 minus 1 is 2, which is the same thing we got before. For number 5, it says, what if a new student joins Miss Lee's class who walks 3/4 of a mile to school? How would the line plot change? Explain. So if we had a new kid come in that walks 3/4 of a mile, how would what you just drew up here, how would this change? Explain to me how it would change. So how would your line plot change? Okay. One answer could be, there are many answers and many ways to answer this problem. One way you could have explained it is that you would add another X above the 3/4. So that's what I'm going to write here for mine. If you had anything similar to that, that said you were going to put another mark above 3/4, then your answer is correct. Okay. So I'm just going to put I would add another, excuse me, x above 3/4. Okay, I would add another x above 3/4. Again, if you have anything similar to that, your answer is correct. There are many ways to word that. All right, our next one says, a food critic collected data on the length of time customers waited for their food. Order the data from least to greatest. Make a tally table and a line plot to show the data. Okay, so this is all of the data he collected. They want us to make a tally sheet and a line plot. So they have taken out this step of writing them all out like this. Now we're just doing our tally sheet and our line plot. We still need to do it the same way though, writing our smallest fraction up to our biggest fraction. When I look over here, I see that I have some denominators of 4 and I have some denominators of 2. I will need to make common denominators so I know which fractions come first, second, or last with the ordering. I also see a whole number, 1. So remember what a 1 represents. A 1 is equal to your denominator from your problem on the top and the bottom of your fraction. So it's in the numerator and the denominator. So in this case, we're looking at 4. So that means 1 is equal to 4/4. And then we have our 1/2 again. And we would say what times 2 is going to give us that 4 on the bottom that we want. We would say 2 times, good, 2. If I do it to the bottom, I have to do it to the top. So 1 times 2 is 2. So just so we know what these numbers look like as a fourth for when we are ordering them from least to greatest. So as I look, I see I have 1/4, I have a 1/2, which is a 2/4, 3/4, and then a 1, which is a 4/4. So I'm going to put these in order from least to greatest. What is the smallest of those fractions? Good, 1/4. My next fraction would be, good, 1/2, which is the same thing as 2/4. I'm going to keep it as a half because that's how it's written in my problem. Next would be, good, 3/4. And finally, I would have 4/4, which is equal to a 1 in my problem. Now, for doing your tallying of how many of each you find up in your data, my suggestion is to go one at a time, cross it off of your data, put it into your tally sheet, like so. So I have a 1/2. I'm crossing off this 1/2. I'm writing my line in. My next one is 1/4. Cross it off, write a tally. Okay. 3/4, 1/4, 1/4, 1/2, and 1. Okay. Now my tallying is done. I need to complete my line plot. So again, these little lines are for you to write in your fractions from least to greatest. So all you have to do is copy your chart and copy this out of your chart. So I start at the top, I would put 1/4, then 1/2, 3/4, and 1/2. The bottom line is for naming your line plot. What are you measuring here? So remember, we can find that right here. And we want to make sure we put in how we are measuring. So I'm just going to put time customers waited. For food in hours. Okay. And now I can take my tallies and make my X's up above. When I look at 1/4, I see 3 tallies, so I add in 3 X's. For my 1/2, I see, good, 2 tallies, so I need 2 X's. For my 3/4, I see how many tallies? Great, 1, so I only add 1 X. And for my 1/2, I have 1, so I add 1 here. Okay, now my tally sheet is done, and so is my line plot. I have a couple questions to answer about this data. Excuse me. All right. 2 says, on how many customers did the food critic collect data? Okay, this is like that first one where they were asking how many buttons are in her collection. Okay, so on how many customers did the food critic collect data? Well, that's everybody that was in this box, because that's the data he collected. So that means every single X I put or every single tally mark. So I could count up either. I could count up the tallies, I could count up the X's, or I could count up the numbers in the box here. Any of those 3 ways would work. I find it easier to count the X's once I've made them, but whatever is easier for you. Okay, so I would add 1, 2, 3, 4, 5, 6, and 7. Don't forget to label. What are we talking about? We're talking about customers. Your next question says, what is the difference between the longest time and the shortest time a customer waited? So again, there's a couple ways to do this. You can do a subtraction problem, or you can hop backwards on your line plot, starting at your biggest and hopping back a spot at a time. So 1, 2, and 3, and that goes over your same denominator. I could have also taken my 1/2, which is 4/4, subtracted 1/4, then I would have gotten my 4 on my denominator, and 4 minus 1 is 3. Now it's not just 3/4. I need to make sure I label with what are we measuring in? Hours, or an hour. 3/4 hour. Alrighty. I want you to pause the video right here. Try this for yourself, and then I'm going to go over it with you. Alrighty. So we're going to go over this one a little quicker because you should have tried it on your own first, and we're going to see if you got it right. Okay, so as we looked in our data here, we would put them in order from least to greatest. I see 1, 6, 2, 6, 5, 6, 3, 6, 2, 6, 6, 6, 3, 6, 2, 6. So my smallest one out of that would be 1, 6. And my next smallest I see is 2, 6. One thing you should have noticed is that all your denominators are the same, so you don't have to worry about converting anything. Okay, my next number I see is 3, 6. All I have to do is look at my top numbers and order them from least to greatest because my denominators are the same. Then I have 5, 6, and 6, 6. When I go to put them in my chart, you might have noticed that there's one extra line. That's because as we look down, we see 1, 2, 3, 5, 6. What was missing? Wonderful, 4. Okay, so you're going to put the 4, 6 on your line plot, even though it's not going to get any X's above it. You still want to have it there so it flows from 1 to 6. So I have 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. I also want to label my line plot, and I'm going to call it ribbon length in yards. Okay, if you wrote out the whole thing, that's perfectly fine. I just kind of shortened it a little bit. Now I'm going to make my tally marks. my suggestion for making tally marks is crossing out as you go. So I would start with the first one, 1, 6, write a tally. 2, 6, write a tally. 5, 6, my tally mark. 3, 6, 2, 6, 6, 6, 3, 6, 2, 6. Now that I'm done with my tallying, I could use it to fill in the rest of my chart. So I look at my tally marks and I say, how many 1, 6 are there? Good, only one. How many 2, 6 are there? Wonderful, there are 3, so I need 3 here. What about 3, 6? Great, 2. What about 4, 6? Good, I tried to trick you on that one. There are none. Remember, we just put that in as a placeholder so that it flowed from 1 to 6 on our numerators. How many in the 5, 6? Good, only 1. And how many in 6, 6? 1, thank you. All right. Number 5 says, what is the difference in length between the longest ribbon and the shortest ribbon? Remember, there are a couple ways to do this. You can jump on your number line, or you can do the math of subtracting out your numbers. So if I was subtracting and find the longest ribbon, which is 6, 6, I would subtract the shortest ribbon, which is 1, 6. My denominators are the same, so it's the same in my answer. I'm going to have 6 minus 1. Good, 6 minus 1 is 5. So I'll have 5, 6. I'm going to check the other way to make sure that it works. I start at my longest and I go backwards. So 1, 2, 3, 4, 5. And I would put that over my denominator of 6. So 5, 6. Don't forget to label this by what are you measuring with. In this problem, we're measuring with a yard. 5, 6, yard. Alrighty. Our next one, they've already given us a line plot and just have some questions for us to answer. So the line plot shows the difference of those students in Miss Boren's class ran at the track in miles. Altogether, did the students run more than or less than 5 miles? So we want to know, did the students run more than or less than 5 miles all together? What does all together tell us to do? Good, it tells us that we are going to be adding. The other ones we've been subtracting so far. So this one we're going to be adding up. All right. Part A says, what are you asked to find? So what are we asked to find? Good, we're asked to find if the students ran more or less than 5 miles altogether. Okay, so if the students ran more or less than 5 miles altogether. Part B asks us, what information do you need to use? So what would be some good information that they gave us that we need to use? Good, we need to know the distance the students ran, right? We can't tell if they've ran more than 5 miles or less than 5 miles. We don't know what they've run to begin with. So we need to know the distance. I need to know the distance students ran. We need to find this. Find if the students ran. There we go. Okay, so we need to find if the students ran. Would make that a complete sentence. Okay, C says, how will the line plot help you solve the problem? So how does this line plot help us? What does it give us? Good. This line plot is giving us what we said we needed in part B. We need to know the distance students ran, and that line plot is giving it to us. So the line plot tells me how far each student ran. Okay, tells me how far each student ran. Part D says, what operation will you use to solve the problem? What did we already talk about up above? What do we use to get the all together? Good, addition. Okay. Part E says, show the steps to solve the problem. So we're saying we're using addition, so then we would have to add up all of our check marks, which means I would have start at my least one, add that fraction for every time I see an X. So with 1/5, I see two X's. So I would write 1/5 plus 1/5 plus, remember I'm adding all of them together. Go to my next one, 2/5, I see 2. So I would do 2/5 plus 2/5 plus 3/5, I only see 1. Then I have 4/5, so I see 2. And finally, I see 5/5, and I see 1. So that's kind of our first step. Our second step would be to add them all up. So 1 plus 1 is 2, plus 2 more, so 2, 3, 4. 2 more from 4 is 6. 6 plus 3 is 9. 9 plus 4 is 13. 13 plus 4 is 17. And then 17 plus 5 makes good 22. And it stays over my denominator of a 5. Now this is an improper fraction, so I cannot leave it as it is. Let's say, how many times can 5 go into 22 without going over? Good. It can go in 4 times without going over. And I would say 5 times 4 is 20. And then 20 plus what makes 22? Or 22 minus 20 equals 2. So 4 and 2/5. So to finish off F, we need to use this new answer we just got. The students ran a total of 4 and 2/5 miles. 4 and 2/5 miles is greater than or less than 5 miles. Good, it is less than. So altogether, the students ran less or more than 5 miles. Good, less. Sorry, here we want to do our alligator mouth. So we're going to change this to alligator mouth. Less than. Okay. Number 7 says that Lena collects antique spoons. The line plot shows the length of the spoons in her collection. If she lines up all the spoons in order of size, what is the size of the middle spoon? Explain. Okay, so what spoon would be in the middle if I lined up all of my students from end to end to end and kept going. So the easiest way to do this kind of problem is to cross out your information on your chart as you go. And how we want to do this to make sure it's fair and that we're getting the middle is we're going to take one from the smaller side and one from the bigger side every single time. So as I take a 1/4 here, I want to take my 5/4 over here. I have another 1/4, it's going to take out a 4/4. My next smallest is a 2/4. Still have a bunch of 4/4, so I'm going to knock another one out. My next one is a 3/3, cross that out, knock out another one of these, and I'm left with one left over, and it asks you how much length is that? Good, it's 4/4 feet. So they need a whole foot. Okay, and when you're explaining, you can tell me exactly what you did. So I crossed out one smaller and one greater. I crossed out one smaller and one greater value until I found the middle. Until I found the middle number. Okay, our last one for the together section here just asks you to make or take this data and put it into your chart. They've already labeled it for you. You just have to write them from least to greatest and then put your X's up above. I want you to try that now. All right, so as I look, first thing I want to look at is my denominators, and all of them are the same. They are all 8. So now I just have to look at my numerators, and I'm going to pick the smallest number and move upwards from there. So if I look, my smallest number is 4/8. And I see 5/8, 6/8, and 7/8. I just need to put my X's in my chart for where they go. So I have 4/8, I have a 5/8, 7/8, 7/8, 5/8, 6/8, 7/8, 7/8, 6/8, and that is it. Alrighty, what you guys need to do before you see me is your homework page. So for your front page here, you have some data. You'll have to put it in a tally chart or on a line plot like these two down here. You might have a couple questions to answer about your chart. On the back, you have a line plot that they want you to answer questions about. Okay, so how many students were reading during the story time? This is how many students total, and then how many students spent that time. What's the difference from the least to the greatest? You should be able to do all of the spiral review down here. The bottom two are things we've done in the past couple lessons. The top 2 here are things we've done in our previous unit, unit 9. Okay, so you should be able to do all of this. And I will see you at 2:20 so that we can go over it. One little change to our schedule this week. Tomorrow, you guys will not have a math lesson. You guys will have a reading lesson with Miss Evanson. And then on Wednesday, we're still playing it by ear, whether you'll have a math or a reading that day. and whichever one you don't have that day, you'll have on Thursday. We'll send out the schedule as early as we know what's going on. I have another meeting that I have to attend for the school district tomorrow, so that's why Miss Evanson's going to do her lesson tomorrow. And if that meeting doesn't get finished tomorrow, then we also have to do it on Wednesday. So that's the reason why we don't know yet. We might get math on Wednesday, or we might get reading on Wednesday. And whichever one we don't do on Wednesday, we'll do on Thursday. So I will see you guys either Wednesday or Thursday for your next math lesson when we go over 4.6, sorry, not 4.6, 12.6. I don't even know what I'm saying right now. When we go over 12.6. All right, guys, see you later.